theories happened over a long period of time, some of them even by accident. So let's take a look at the thousands of years of work that went into creating the world we live in today and some of the people who got us here. Let's start this in the 7th and 6th century BC with a man named Thales of Miletus, whom some consider to be the father of science. He's known for his attempts to explain phenomena through theories and hypotheses rather than mythology. For example, although this may seem like nonsense to us now, one theory he had was that all matter was made up of a single substance, and that was water. He may have missed the mark on that one, but it is believed by some that he was able to predict a solar eclipse on May 28, 585 BC, now known as the Eclipse of Thales. This eclipse actually interrupted and may have helped end a war between two local kingdoms at the time. Now fast forward to the 5th century BC when philosophers came up with a new theory that matter is not made up of just water, but a collection of elements. Water was one, the others were earth, air, and fire. Several years later, Aristotle also suggested a fifth element known as aether that made up celestial bodies, since stars probably would not be made of the same elements found on Earth. He definitely would have been shocked to learn that they are in fact made up of elements found here on Earth. But even though we know these classical elements to be wrong, they do align quite well with these four states of matter we all know of. Now those are some ancient theories, but where I really want to start this video is with a story I'm sure many of you know of, which begins with a gold crown and a bathtub. In the 3rd century BC lived scientist, engineer, and mathematician Archimedes, who contributed more to the world than any other scientist of ancient times. Probably his most famous contribution was made while he was taking a bath. Archimedes needed to calculate the density of a supposedly gold crown to determine whether some silver had been substituted by a dishonest goldsmith. He was not allowed to melt the crown to a normal shape in order to perform calculations, though. One day while taking a bath, he noticed the level of the water rise as he got in, and he used this principle to determine the volume of the crown, since the crown would displace its own volume in water. He was able to then calculate the density of the crown using mass over volume, and concluded it was less than that of gold, proving that silver had in fact been mixed in. Later, Archimedes went on to write on floating bodies, where he continued his research into submerged objects. In this, he describes what is known as Archimedes' principle, which states how the upward buoyant force exerted on a body in a fluid is equal to the weight of the fluid displaced by the body. This principle is why you feel lighter when in water, or why it is very difficult to push an inflated beach ball underwater. Now, the story of the gold crown has actually been called into question due to the accuracy needed to measure the water displacement and how difficult that would be given the instruments available to Archimedes. Instead, a more practical technique that actually makes use of Archimedes' principle would be to suspend the crown on one end of a scale and balance it with an equal mass of gold on the other. Then when put into water, the crown would have displaced more water than the gold due to its larger volume, and thus experience a higher buoyant force, making it more apparent it was mixed with silver. Now, physics is not just a foundational science, but it's also the basis of technology. New physics discoveries today lead to new technologies tomorrow, and this goes way back. During ancient times, many Greeks were interested in the development of machines. For example, Archimedes is recognized for the invention of various networks of pulleys and levers. His famous quote is, "Give me a place to stand and I will move the earth." This, of course, has to do with mechanical advantage and the amplification of applied forces. Machines that make use of mechanical advantage allow us to, let's say, lift a car using only our own strength. One notable invention of his was the claw of Archimedes that used mechanical advantage as a weapon to defend a portion of Syracuse's city wall during the Second Punic War. Its exact design is unclear, but it worked kind of like a crane using pulleys and levers to lift enemy ships slightly out of the water, causing them to eventually flood and sink. Nowadays, simple things like bottle openers, nail clippers, hammers, bike gears, wheelbarrows, and more make use of these principles. Now let's fast forward all the way to the 11th century when a physicist known as Ibn al-Haytham changed the way we think about light. Although a lot of research has been done since, al-Haytham is considered the father of optics. For reasons I won't go into, al-Haytham was kept under house arrest for several years, and during that time he published a 7-volume collection of books known as the Book of Optics, where he proved that light travels in a straight line. He did this through one of the first scientific experiments ever, as a lot of previous theories were simply speculation. Like at this point in time, it was still thought that heavier objects fall at a faster rate, as theorized by Aristotle. This would be proved wrong in a few hundred years, though. Anyways, one experiment al-Haytham performed was he cut a small hole in a wall and hung 2 lanterns at different locations in an adjacent room. He observed that the light illuminated unique spots in the opposite room, and each formed a straight line with the hole and one of the lanterns. Also, for hundreds of years it was believed that our eyes actually emitted rays of light that would bounce off objects, allowing us to see. He was the first to say that in fact light travels from objects and enters our eyes, which is now known to be correct. Now, one thing he was wrong about, even though he did research on them, was rainbows. He assumed rainbows were an image of the sun formed from a curved mirror due to water within clouds. It wasn't until the year 1300 that Theodoric of Freiburg used spherical flasks and glass globes to simulate water droplets that occurred during rainfall. He observed that light refracted onto the droplets, reflected back out, or they were refracted again. Although Al-Haytham did not contribute to our understanding of rainbows directly, Theodoric of Freiburg relied on Al-Haytham's Book of Optics to further our understanding of them. Today, optics has applications in medicine, telescopes, astronomy, laser technology, fiber optic cables, and much more. Next up, just about 2,000 years ago, the first compass was invented, and although people did eventually use these for navigation, no one truly knew how they worked for over 1,000 years. That was until the turn of the 17th century. It was assumed for a long time that compasses were attracted to a large magnetic island on the North Pole. That was until William Gilbert came in and wrote his book where he proved the Earth was actually one giant magnet. In this book, he discusses experiments in which he models the Earth using something called the Torella, or a sphere made out of a naturally magnetized material. When he passed a compass over the Torella, he saw it would always point towards the magnetic pole and behave just as it would on Earth itself. The Torella was improved upon 300 years later by Christian Birkeland in order to further investigate the polar aurora and why it appeared near the magnetic poles of Earth. Now, William Gilbert also did work in electricity. In fact, he is credited with inventing the word electricity, and many consider him the father of electrical engineering. One of Gilbert's inventions was the electroscope, the first instrument to measure the presence of electric charge. Over 300 years later, physicist Victor Hess would use the electroscope to discover something that would win him the Nobel Prize, but I'll get to that soon.
We'll meet nearly 80,000 people in our lives.
If you can't remember my name.
Now, like I said, for over 1,000 years, it was believed that heavier objects would fall at a faster rate. This was introduced by Aristotle, and it seems intuitive, but of course we know now that this is wrong. The story that's been told is around 1590, the scientist Galileo dropped spheres of different masses from the Leaning Tower of Pisa to show that their time to reach the ground was independent of mass, which we now know to be true. He also showed that the relationship between distance and time can be represented by this equation. Although the basic physics here proved to be accurate, many historians believe that this story isn't, but rather it was a thought experiment. Then Galileo did work on pendulums, but also introduced the idea of relativity that would be greatly expanded upon by Einstein. Galileo stated that the laws of physics are the same in any system that is moving at a constant speed in a straight line, meaning there's no such thing as absolute motion, it's all relative. If you were in a rocket ship moving through space at a constant velocity, there'd be no way to determine if you were moving or actually stationary. Your brain probably is telling you that these asteroids are passing by a still observer right now, but look at it some more and you can probably convince yourself that the asteroids are still and you're moving past them. Galileo's work not only set the foundations for Einstein, but also provided the framework for what Isaac Newton would go on to discover. In 1687, Newton published the
Yeah, man, just studying, hardcore studying all day. yeah. So, do you have trouble studying? You get distracted by the TV? You find yourself on YouTube all day? I know you do. You're on YouTube right now. In this video...